All right, here we are. We're going to be learning about two words. One is congruent and one is similar. And congruent means everything is exactly the same. So, when we're talking in terms of math and in terms of particularly shapes, and today particularly triangles, even though these aren't triangles, don't let that sway you. Here's the deal. Something that is congruent means every angle is the same, and every side length is the same, and everything about the figure is exactly the same. So when you look at this book right here, and then you look at this book right here, they have the exact same dimensions. That means they are congruent. Now, just for a little preparation for later, if they are congruent, and they are, I just told you they are, and then I turn this one sideways, is it still congruent? Yeah. What about if I flip it upside down? Is it still congruent? Yes. Don't worry about it flapping around. That's fine. What about if I turn it like this way, kind of awkward, whatever? Are they still congruent shapes? And the answer is yes. It doesn't matter which way it's facing. It just matters if it has the same angles, like all the corners are the same, and the same size and the same side lengths. That means congruent. Other word, similar. In a similar figure or in a similar relationship, it is the same shape, and it has the same angles, but it may be a different size. Example, I've got this little Mr. Campbell math dollar thing I've got. It's a rectangle. It's got a 90-degree angle in each corner. Then I got this piece of paper. It's a rectangle. It's got a 90-degree angle in each corner. And these two figures are similar. So small rectangle, big rectangle, as long as they have the same angles and they are the same shape and they have the same ratio of dimensions, then they can be similar figures. Keep that in your head. You can probably look around your house and find all kinds of things that are either similar or congruent. Congruent means exactly the same. Similar just means mostly the same. Probably the only difference is going to be the size. You may have a smaller figure and a bigger figure that are similar. Like this. If you look at all these triangles and you ask yourself, are they similar? Are they all the same shape? Well, yeah, they're triangles. Do they have all the same angles inside the triangle? And maybe that you can't tell because they're all spread around. What about if I showed it to you that way? Okay, where you can see, yeah, well, when you look at it that way, it looks like every angle is similar. As you go around, they all have the same angles inside the triangles, and that's what makes this set of triangles similar to each other. I think you're up. Yep, Miss Walton's going to show us an example here.
All right, so there is a large word up here. It says postulate, angle, similarity postulate, which is just saying that if you have...
Pardon the interruption. At this time, please stand for the pledges. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now the Texas pledge. Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible. Please hold for a moment of silence. Thank you.
So the angle similarity postulate is just a fancy way of saying that if you have two angles on one triangle that are congruent, meaning they are exactly the same, like Mr. Campbell just said, two angles that are exactly the same to two angles on another triangle, then the two triangles are similar. So in this example down here, we have a triangle that has this degree says 100, write it a little bit bigger for you. This says 45. This says A, and then over here on this second triangle we have 135. So without any further math, these two triangles, according to this definition, would not be similar because this is 100 and this is 100, which are congruent. But 45 is not congruent to 35. But since we have these two missing angles here, we can use the triangle sum theorem to figure out the third side length or the third angle of our triangle. So over here, we would add these two up, 100 plus 45, which is 145, and then we can subtract that total from 180 to get our third angle, and A is 35 degrees. So we can do the same thing on the other side. We have 135, and we're going to subtract that from the total amount of 180 and get our total for angle B, which is now 45 degrees. So now that we've filled in all three angles of this triangle, we can go back to our definition of a similar triangle, and we can see that we have 100 and 100, and then we also have 35 and 35, or even 45 and 45. So because we have our congruent angles, we know that these two triangles are similar. So, as another practice here, if we were to fill in these two triangles, we're asking ourselves if they are similar or not. And if we were to say that this one were 95 degrees, and we had another side length, or another angle that was 20 degrees, and on the other triangle we have a 20-degree angle, and then we have something like 75 degrees. So with the insides of these triangles, we know that in order for them to be triangles, the total has to be 180. The total has to be 180. So we need to figure out if we are going to find with these triangles we'll have two similar angles, because right now we only have one set of congruent angles. So again, using the triangle sum theorem, we will add up 95 plus 20 and get 9, 10, 11, 115. And if we subtract that from 180, we will get, can't do this in my head, 7, 10 minus 5 is 5, 7 minus 1 is 6. So we'll get 65 degrees here. And over here we have 75 plus 20, which has 95. So if we subtract 95 from 180, we get 10 minus 9 is 1. Is that right? 115? 115 degrees. So as we ended, we only ended with one pair of congruent angles, 20 degrees and 20 degrees, and none of the other ones are congruent, so these two are not similar.
So you can do this with the angles, but you can also do it with sides. So real quick, I want to show you this. If you are given like a number over here that says that side is 2 and that side is 2 and then that side is 4, and then on this other triangle you're given a number that says this side is 6 and this side is 6 and then this bottom side is 12, you can also use that information to figure out if the triangles are similar, even though you don't have any angles, okay? When we did angles, we tried to make sure the angles were the same, and that's what Ms. Walton showed you. But if you have information about the sides of the triangles, then you're actually not looking for the exact same numbers, you're looking for the exact same relationship. And here's what I mean. This 2 right here on this side has a relationship with this 6 because they both represent the corresponding or the same side of a triangle. So I'm going to take this 2 and just put it up here and compare it to the 6. Okay, it's smaller than the 6, and so I'll just put 2 over 6, see what the relationship is. And then I'm going to do the other side of the triangle, these two sides that are corresponding, and I'm going to also do 2 over 6 right there. And then the third side is going to be the 4 compared to the 12. And here's what's going to happen if you calculate those out, if you take those 3 fractions. 2 over 6 will simplify to 1/3. 2 over 6 there will also simplify to 1/3. And then 4 over 12 will also simplify to 1/3. Now, if you don't feel great about simplifying fractions, you can just put it in the calculator and get a decimal, and they would all make the same decimal, 0.333 eternally. Bottom line is this: if you get numbers around the edge, then you want to compare the same side of each triangle with each other and then see if there's a pattern. Now you've got to do this correctly in order. So if you start with 2 over 6, then you've always got to start with this triangle's number. So the 2 over the 6 and the 2 over the other 6, then the 4 over the 12. If you started the other direction, if you started with this side over 4, you could do that as long as you did 12 divided by 4 and then 6 divided by 2 and then 6 divided by 2 there. So you just have to be consistent with your comparison. Let me make a sports analogy. If you take 2 guys and they're trying out for your basketball team and you tell one guy, hey, go shoot 50 free throws. And he's right-handed, so he shoots his 50 free throws and he makes 40 of them. That's pretty good. Then you tell the other guy, you got to shoot 50 free throws, but you have to do it left-handed, okay? And he's not a left-handed person. Well, you're not really comparing them well because you're making one guy do it one way and then the other guy do it a completely different way. So when you're comparing the sides and trying to find the relationship, go through the same pathway each time. 2 divided by 6, 2 divided by 6, 4 divided by 12. Always start with the numbers on that side. Okay, that's that. So if we looked at this and I said, are these triangles similar, or are they congruent, or are they neither? Then this is what you should think. This little notch right here is a congruency mark. It means that this side is the same as that side. And then this notch means that this side is the same as that side, and then this side is the same as that side. Now, if those are the same, and those are the same, and those are the same, that means it's congruent, right? Because everything on this shape is the same. So out of these options, you would want to pick congruent. But then I would show you this, and I would ask you the same question again. Are these congruent? And you might look and you go, well, that's not the same as them, that's not the, and now it looks totally different, right? And so you might pick neither, or you might pick similar if you think they're similar, but in both cases you'd be wrong because when you are looking at shapes and comparing them, you always have to be aware of the perspective from which you're viewing the shape. See? It's actually the same shape that I just showed you on the last slide, but I turned it. That does not change whether it's congruent or not. To get back to our original question, these two things are congruent. Same shape, same size, everything. Just because I turn it doesn't make it non-congruent anymore. It just changes the way that we see it. So if they're congruent no matter where they go. Keep that in your head. Reset, move on. This is the end of the triangle similarity video. Enjoy.